We usually write a number in scientific notation if it's either a really, really small value or a really, really large value. So like number 6 down there and number 7, like number 6 is super, super small. Like look at all those zeros. And then the 6, 8, 9 at the end. And then 9 with all those zeros after it for number 7. So when something is either really small or really little, we'll write it in, or really small or really big, we'll usually write it in scientific notation. And the number is written in scientific notation when it's in the form of C, which is just any number, times 10 to some power. So C needs to be between the values of 1 and 10. So as long as it's greater than 1 and less than 10, meaning it would be a single digit. So C should be like 2 or 4 or 8. It shouldn't be 13 or 0.12. It needs to be a single digit, C does. So let's look at writing some numbers in scientific notation. So let's just do a couple. So number 1, 12,000. So what happens is we want the decimal essentially to be behind that first digit because we want it to be a single digit less than 10. So what happens is we really want this to be 1.2. But what we need to figure out is times 10 to what power is the question. So really, even though you don't see it, the decimal place, if you don't see it, is always at the very end of your number. So from the end of that number to in between the 1 and the 2 there, how many place values is that? So 1, 2, 3, 4. That's your power. Every time you move a place value, since we work in tenths, each place value is 1 power for your 10 there. So 12,000 would be 1.2 times 10 to the 4th. So we want the decimal right behind that first digit. So in this case, we would want the decimal to be right there. So from the end of your number, 1, 2, 3, 4, 5, 6, 7. So it's going to be times 10 to the 7th, and you just need to include any numbers other than 0. So we just need 2 and the 3, 2.3. That decimal goes right after that first number, always needs to be a single digit there. So how about 0.00021? So this time I see the decimal place. We want it to be, again, right behind that first digit. So from here to where it needs to be, that's 1, 2, 3, 4. So here's the difference between number 3 and the ones we just did. This is going to be 2.1, but it's going to be times 10 to the negative 4th. So you move your decimal value, when, I guess, you move your decimal value to the right, you get a negative exponent. When you move it to the left, it's going to be positive. So anything that starts out as a larger number gets a positive exponent. Anything that starts out as a small number gets a negative exponent. So for 1 and 2, 12,000 and 23 million were both larger than 1. So their exponent, 10 to the 4th, 10 to the 7th, were both positive. But for number 3, that number was smaller than 1. It was 0.00021. It was 2100 thousandths. So when you move that decimal, it became a negative power. So numbers larger than 1 should have 10 to some positive number. Numbers smaller than 1 should have 10 to some negative power. So for number 4, we're still going to move that decimal value right behind that first number. So we want this to be 3.45 times 10 to some power. What power specifically? Well, let's count from the end. 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th. 3.45 times 10 to the 8th. So 0.0478, we want that decimal to be right behind the 4. So it's going to go right there and be 4.78, but times 10 to what power? We moved it 2 places, 1, 2, but it originally started as a number smaller than 1. So a negative power, negative 2. Moved it 2 places, negative 2 because it was smaller than 1. How about number 6? Really the trick with these guys is just making sure you don't accidentally miscount. So don't do it so quickly that you miscount what your place values are. But for this one, we want the decimal to be right between the 6 and the 8 there. So it'll be 6.89 times 10 to what power, though, is the question. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 places, but negative or positive. 11 is the question. It is a number much smaller than 1, so to the negative 11th power. And then how about number 7? We want that decimal point to be right there between the 9 and the 3. So 9.3 times 10 to what power? So 3, 6, 9, 12, 13, 14, 15 places. So every single one of my numbers in scientific notation has one single digit in front of that decimal place. It should never be more than 1. So it shouldn't be 21 or 12 or 15. It should be one single number, one single digit in front of that decimal when you are moving or making it scientific notation. And just also remember, larger than 1 gets a positive power, smaller than 1 gets a negative power. So when we go the other way and convert it into decimal form, if it's a positive power, that means we should end, vice versa then, with a number larger than 1. So when we see a positive 4 there, we should know that we need to make this number larger than what it currently is. So 2.31, you can rewrite it if you want, just so you can sort of move the decimal place. We need to move that 1, 2, 3, 4 places to right there. Any empty space you have is going to get filled in with a 0. So this is going to be 23,100. And I knew it was going to be larger than 1 because the exponent was positive. So positive exponent, you move it to the right. Negative exponent, like number 9, we're going to move it to the left. So if it helps to rewrite it, go ahead. We're going to move this decimal place 2 spaces, put it right there, and that means we need 1 0 in there. So 0.089. And then 3.05 times 10 to the 8. So 3.05. And we need to move this decimal place 8 spots. So 1, 2, 3, 4, 5, 6, 7, 8. So we need 6 zeros. So 305, 6 zeros. So 305 billion. So sometimes it's just easier to write something in standard or in scientific notation instead of having this really big long number, and we should still understand or know what they both mean.